we are moving to Python module, right? So Python modules are very important concept. Why? If you write your code in a single file, suppose you have created a file in which you have, suppose you have created a file, suppose you are creating a uh, logic of logic of chess, right? You are creating your chess.py file and you have written maybe 1500 line of code. Now in this file you have written 1500 line of code. Now it is very difficult to handle this. Right now only 1500. You may also have other files, or maybe your code will increase in future. You will add more functionalities. So suppose initially it is 1500 lines, then it become 3000 line after adding certain functionalities, right? So in that particular case your code size is increased. Now it is very difficult to handle this code. Right now if you see, yesterday when we were writing code, we were writing 4 line, 6 line, 8 line code, right? But when your code lines are increasing, you have multiple, suppose you have your multiple functions, right? Function 1, right? Function 2, right? Function 3, and so on. Suppose you have 15 function inside this, and you can group these function into different categories. So instead of keeping whole code into a single file, you can create multiple modules, right? You can create multiple modules. So you can divide your this 1500 code into two files. In one file you keep few functions, and remaining function will be another file, right? So this is very important for modularity purpose, for reusability purpose, for encapsulation purpose, for easy organization purpose. We need to create multiple modules, and module is nothing. The .py file is our module. In Python, the file you are creating with the extension .py, and in our case we are using IPython notebook. So this is a single file, right? So .py is your module. So in you can add your code into single file, but it is recommended that for modularity purpose, for reusability purpose, you can create multiple modules as per your functionality, right? And you can define your details into this, into each module, right? For example, math module has all mathematical operation. OS module has all the operating system operations. Random module has all the random function details, right? So module is a Python file. What it is? It is a Python file that is used to achieve modularity, reusability, encapsulation, and easy organization of code, right? This concept is very important, right, when you deal with large size of code. Okay, now what happens here, there are so many types of modules in Python, right? OS is there, sys, you have seen, time, date time, random, math, we have used sqrt function, right? There is also for regular expressions, a collection is there, iter tool is there, func tool we have used for reduce, if you remember, right? Yesterday we used a reduce function coming from func tools, right? So these modules are important, right? So you should know how to create module and how to import them. Importing them is also important, how you are importing them, right? I will explain you this, but before this is important, right? A module is a single file, right? Or when you say modules, it can be multiple files into one package. So package is a combination of modules plus sub packages. Package is nothing, just a folder, So if you create a folder and in which you have multiple modules, for example, you have one module for sorting, right? One module of searching algorithms, and another module you have for hashing, right? So hashing.py, searching.py, sorting.py. It has all the sorting function, searching function, and hashing functions. So this folder has these three files, right? So this folder package may have multiple modules, a collection of modules, plus there will be also one more file here. There will be also one more file is here, which is underscore init underscore underscore dot py. So this is empty file you will have. Empty file. In general, you will have empty file. If you want, you can write something into this, but we keep this empty file via these three files plus this. Via this file, interpreter will identify whether this folder is a package or not. This folder is a package. How interpreter will identify? Using this file. This file should be there. All the modules should be there. Suppose your folder name is DSA, data structure and algorithms, and you have written sorting algorithm like quick sort, merge sort, right, or bubble sort, right. In searching you have written linear search code, right, and your binary search, and here you have written some hashing functions, right, hash functions. Okay, hash functions. So folder name is DSA, but we also should have this file. Then interpreter will identify this as a package, otherwise it is a folder. Okay, so a package is equals to folder plus this init. Okay, this init underscore dot py file, this file, and this folder also has certain dot py files or your modules, right. So in summary, what I can say, this is your package. In package you have modules, right. Modules means dot py file, and you also may have sub package. It means folder inside a folder. You may have another folder, right. Folder name is tree, for example. This tree will also have a certain algorithm. Okay, like suppose it has one traversing dot py. Suppose it has another file traversing and add node dot py, for example, right. So this tree will also have one more file. This tree will also have one more file, which is underscore init underscore dot py. So this file will be into this, then this folder will become a sub package, right. So that's how this mechanism work. If you see any library or any package, it will have sub packages and modules. Okay, so this is very important in Python. And how you will import this? Import module name. For example, import math, right. Import math, as simple as that. You can also import package, right. Package name, and then you will write your module name or maybe sub package name. From that you can import a particular function also, right. I will show you this. Don't worry, with the help of example I will show you this, right. Before this, yeah. So import module name. You can import multiple modules in single line, but it is not recommended. Recommended is in each line you should import one module. You can also import like this, from module name import name. For example, here I am writing import math, right. Here I can write from math import sqrt. Yes, we have used this function. Only import this function, not all the function. Okay, and you can import all the function from math like this, from math import star. It will import all the functions from math, functions, variable, everything. Okay, so this is how we import them. Okay, and one more important thing, how to create a function. It's not function, module. You can create any file, hello.py, demo.py. It is your module. Suppose I have created a file in which I have only one function. So this function I have created with hello.py. Then I can import hello and use this function hello world, just like I was using, right. Import math.sqrt, right. Same way I'm doing here. I can create my own module. That is what we need to learn. How can we create own module and packages? And this is what you will going to do in your project, right? If you see, lots of project file look like this. If you see here, this example here, my library, this is a folder. You can see this init.py file. These are two modules. Then setup.py, readme.md, license, requirement.txt. You can see these on GitHub. I will suggest you go on GitHub and try to see any library. Let me show you, right? Let me show you one library. Pandas. Okay. Pandas GitHub. You can check any library, right? No issues in that. Right? Let me open math GitHub. Let's try. I have no idea whether it is on GitHub or not. Math Python, right? Okay, C Python module, math module at C. No, because this is a module. This is library, right? Let's open this. Let me show you this. You can see this is Pandas. Pandas is a library which is used for creating tables, sheet, the Excel kind of work you can do into this. So you can see here it has license. Okay, you can see this Pandas folder. In this we have all the code of core Pandas. Right? It is updated 17 hours ago. You can see how you can see the activeness of community, right? Okay, and then you can see here, you can see readme. Here you can see requirement dev.txt, right? Other YAML files you can see, right? You can see other folders also. In this folder you can see some other sub packages, and you can see other modules also. You can see this core, pandas.core.frame, pandas.core.frame. Guys, frame is visible here. Frame, no, pandas.core. Okay, frame is here. You can see frame.py is module, where inside pandas is a package, core is sub package, and frame is here. If anyone remember pandas.core.frame.data frame, if you recall, if anyone has did data frame, now you can see we have here a class data frame. Let me show you a data frame class. You can see this is a class data frame that you use to create the data frame. So you can see this is a package, sub package, and module, and then this is the class. So how you import this? If you want to import the data frame, how you import this, right? So these kind of things are here. That's how modules works. Okay, let's create your own module, right? Okay, let's create your own module. Yeah, before that, anything you want to ask, anything that you want to ask, then we'll try to create our own module and try to see few things, and then I will explain you other concepts. Anyone, anything? Sub package. So sub package is a same folder or same package inside other package, right? So you can see here a package has multiple modules, right? In this example it has two modules, and it has one init file. Similarly, if you create another package here, let me try to explain you via writing, right? So this is a package, right? Inside this, suppose we have one more sub package name, right? Sub package. Now this sub package will also have this file, right? And it also has its own module, like module 1.py, module 2.py. It will also have, it may have multiple modules, right? As I shown you in case of Panda, it may also have more. So inside a package you are having a sub package which also have the similar structure, and this file is compulsory. Similarly, sub packages are subdirectories with their own init.py file for sub package. Every sub package will have this file init underscore underscore init underscore underscore dot py. Generally it is empty, but you can add information here about your modules and classes. I will show you that, but yeah, in general it is empty in general, right? But you can add information about your class and modules. Yes, any other doubt? Yeah, right, absolutely right. For example, suppose you are creating a scientific library, right? Scientific operations. You are creating a library, scientific operation, SciOps, right? I'm giving this name SciOps. In this, you will have multiple modules, right? Like for example, integration, right? Integration, matrix operation, right? You will have differentiation operations, right? Differentiation, right? And other mathematical operations. Okay, maybe geometrical operation, maybe other trigonometric operation, right? Okay, right. So these are sub packages. This is your big package, these are your sub packages. Inside this you may again have, like for example in matrices you may have again two packages, right? For example, one package you have for decomposition. Decomposition means you are decomposing your matrix into two parts, right? Singular value decomposition and matrix factorization, factors of matrix. And another you have basic matrix operations, right? Okay, so geometry may have 2D and 3D, right? So these are sub packages. Inside this you will write algorithm for doing those operations. So these kind of library will be there, and every project has this structure. Whenever you work on real project, you will see this folder structure. This folder structure depend upon on which project you are working, but it will have. Okay, right. Let's move ahead. Any other doubt? Yeah, we are bundling this. Not only bundling this, we are modularizing it. No, a word is modularize it. Why? Modularized approach is much more easier to handle. So, and you can also reuse this, right? Reusability is also there. Without inheritance you can also do the reusability, right? Suppose in math module you have written sqrt function. Now you don't need to rewrite it again, right? You just use this function. Math also have value of I, you can easily use that, and math also have other functions, you can easily use those functions instead of writing your own. So it also bring you reusability and encapsulation. It is encapsulating things, for example integration into a single folder or a single sub package. So you are also doing encapsulation, right? Yeah, of course it is not that stricter relationship here, just like your oops, right? But still they are encapsulating the similar kind of functionality into a single unit. Okay, so that is why this package and modularity, modules are important, right? Similar to if you see C++, Java, you create folders and multiple files inside folders. The same way you will do here. Okay, this is how it works. Let me show and create few things, right? So then you will understand, right? So this I was trying to show you. So in this folder I have one package. In that package I have one module already I have, right? Okay, and this is another module which is outside this. Now let me create one folder here, right? Suppose folder name is SciOps, right? psyops we will do in this scientific operation, right? So we have this folder, but this folder is not package, right? To make this folder package we need one file underscore underscore init underscore underscore dot py, right? Now it is your package. This is not a package, this is just folder, right? In this we can also add more folders, like let me add one folder of matrix, right, or matrices, right, matrices, okay, and one more I will add for geometry, okay, not inside this here. One more I am adding geometry, right, geometry, okay. Now inside geometry you can create your folder. We right now we don't have anything, but first I will add underscore underscore init underscore underscore dot py. Now it will become a sub package, right? Now inside this I am creating another folder, a 2D, okay, and I am creating one more folder which is not inside this, inside this 3D, right? Now you can see in geometry we have underscore underscore init and these two sub packages. In psyops this is sub package and these are again sub package. Sorry, I need to rename this 3D, right? And still these are not sub packages. I need to create one file again. Each folder will have this file, by default this file. Now we can create our functions here over our file here. For example in matrices, or for example here in 2D 3D I want to add one more file, right? Input pre-processing, right? We want to pre-process user input, right? So we will keep all the function here dot py, all the pre-processing function I will keep here, like for example def pre-process, okay, pre-process, okay, pre-process integer value, pre-process int, right? So I'm printing here integer variables pre-process integer variables, okay, something like that, right? Sorry, variables, okay. So you can see this is how the structure is, sub package, package, and you can call them, right? For example, let me try to call this. Now I am in which folder? Online class project, in which I have these one folder, I have these folders, right? So if I write here okay, ls, because I am in Ubuntu, right? It is saying you have mode1.py, psyops and pack1, right? Now I want to run that module, this I want to run this, right? Suppose I want to run this here and this function is here, I want to run this, right? Okay, now how I will run this? Python psyops, then this is into, you can see here in psyops this is into geometry, right? Geometry, then input process.py. If I run this, you can see, so I am giving the whole path because I am not into that folder. I have to be in that folder. Suppose mode1 is printing here something, right? Print hello everyone, right? Okay, now I am saving this. Now Python mode 1.py, you can see hello everyone. Okay, so you need to give path because in which folder you are, you need to check and as per that. Another thing is, suppose I want to use this function here, this function input process I want to use here. How I will use? So I will do from psyops dot geometry dot input processes import pre process int. Now I can use that. I am calling that function, right? This function into where it is into psyops into input in this function. So from psyops geometry dot input processes, and I am importing this function and I am calling this function now. Now I will save this control S. If I will run this module 1, you can see pre-process integer variables, hello everyone, and it is printing this 2 times. Because why? The reason is because actually in that also we were calling this function. So you just save this. I am removing. Now it will execute only 1 times, because one time when you are importing this, sorry, we were at mode 1. One time when you are importing it, it is also executing this function, this that I removed now, right? Okay, and second time it is printing this, and then it is again calling that function. So that is why it was showing 2 times. So that's how the functionality will be, right? So if you see any project or anything, it has multiple sub packages, sub modules, and those all the packages will be used in a single file, single main file. You can also use. Right now we are not using that, but still you can use main file, and in that file you can call and print or execute all the operations that you need. So that's how module and packages work. Now one more thing is there, which is your library, right? I want to just summarize this. Just a second. Yeah, sure. Ask, please ask. Sure. Yeah, of course. Yeah, right. Yeah, so it is not mandatory as of now. If you remove that, it doesn't matter. I have tried without this it works right now, but your Python interpreter don't understand this as an interpreter, right? So let's try this, right? Let me try to delete this. Okay, yeah, move to trash. Okay, now control S. Let me try this mode 1. There is no impact, right? But it is a good practice to keep this. That is what I have seen. If you see all the open source projects, like pandas is open source, right? If you see all the open source, they are using this as a habit, right? So Python is not a stricter language. It is not a strict language. Okay, when I will teach you oops, you will say it does not have strictness, right? So just like we have in Java and other programming language. So you can see here in this core also we were seeing the same file here, right? This is a good practice so that your compiler or interpreter will understand. So that is why we use this process. Yeah. So Python is not stricter. Yeah, it can be empty file. You can also add details here. Like for example, if you want to add details about your modules, for example, in this file, you can add your metadata, what modules you have, right? For example, suppose what I will do here is, okay, how I will show you this. Let me show you like this, right? Okay, suppose you can see I'm importing map, right? It will take a minute. Okay, it will take a minute, just a second, right? There is a function named dir, right? When you run this, it will give you whole list of all the keywords which are into this math module, right? You can see all the like signage, sqrt, 10h, all the function and variable it has. It will give you all the details here, right? For example, you can see pi is also there, right? Prod is also there, remainder is also there, right? You can find all the things like is infinity, is nan, right? GCD, you can also find flu, right? So this is called metadata. So this metadata generally defined into the into this init file, right? Let me also check here. I have not checked. Let me see whether they have some information or not. No, it is empty here in this case. Let me check in pandas init.py. You can see in init.py they have defined all the keywords. You can see here arrow, all the keywords are here. Okay, all the keywords, most of the keywords they are defining here. It does not have any functionality, but if you can see, yeah, using this underscore all, in this you will define all the keywords, all the name of modules, classes, so that it will easily identify this, right? You can also see here data frame. Let me see data frame. Do we have data frame here? No, but we have Excel file, Excel, right? All other things. Yeah, we also have data frame. Yeah. So this is basically a namespace kind of thing, right? So this is how you don't need to do. If you see, we do the pandas.data frame, right? If you're aware of pandas, we don't do like this panda.core.frame.data frame. When you check data type, then it will show you. But in general, you can use this. So this basically init is basically for the purpose of defining our metadata. So later when you work on real projects, then you will realize what the exact application of this. But right now, from the concept point of view, we just keep here metadata values. All right. Okay. Is there any other doubt? No. Okay. Let's see one more important concept here. Now, interviewer will ask you about modules, right? About packages. Then he will ask you whether sub package will have this file or not. Then you can say every sub package should have this file, right? Now, next thing is library. You were seeing that pandas is a library, numpy library, matplot library. Scikit-learn is for machine learning. Numpy is for numerical computation, and this is for data manipulation like Excel kind of work, right? It has table, and this table structure known as data frame, right? Data frame is nothing, just rows and columns, right? Rows and columns. And for data visualization, you can use this library. So library is nothing. Library contains related modules and packages for the purpose of reusability code with community. You share this, you create a library and you share with community. So you can see NumPy, Pandas, Matplot, Scikit-learn, these all are open source libraries, right? Open source library, and these library, generally we create library for the purpose of sharing it, otherwise we don't create. If you see the project which are companies internal project, they don't use library in a way. Most of the time they use packages. But some companies in certain projects I have seen, they have created their own libraries, right? I was working with one of my clients. They have their own libraries to handle all the authentication part. So if you will import those functionality, it will automatically authenticate on Azure machine, or maybe on AWS virtual machine, right? So library, again, when your multiple modules, multiple packages combined together, modules, right, packages, and your sub packages, right, all things will be combined and create a library. So library has relative packages, relative sub packages, right? For example, let me compare. Module is a single file, right? Single .py file is a module. For example, import math. It's a very good example. Then package is a collection of module in a directory with init underscore underscore init underscore underscore .py with init.py file. From my package import module, right? Similarly, read it like from scipy, right? From scipy, sorry, sciops, geometry, right? 2D geometry or input pre-process, right? We imported the pre-process int function, right? Similarly, you can use library. Library is a collection of module and packages built in or third party. Generally, libraries are created by third party. We can also create our own for internal use, right? And this we also import, like for example, import numpy, import pandas, right? So this we can do. So module is a .py file. When you create a folder, module is file, package is folder. When these multiple files, multiple folders combines for the purpose of sharing, then you will create a library, purpose of sharing, right? So this we tried, right? This will give you a list of the names, all of the modules, variables and functions that are defined in a module. That is what we used, a dir function, right? Some other thing, what do you mean by encrypted and decompiled? So it, yeah, again it is open source, so they are sharing you the source code, so there is no I have not seen that kind of thing that you are saying. Yeah, nothing to hide here. Okay, right? And one more thing we are using like this, right? Import from math import sqrt, from math import star. Star means all the function you can import. One more thing, we are executing a script using Python keyword and then file name. Yesterday we also tried this command line argument, right? If you able to recall this, we are giving two numbers input here, so it will do sum or sum and return this, or maybe whatever operation we are doing. So understand how we can execute these modules. Okay, now some people will ask, okay, I want to create my own pandas, sir. How I will create? These kind of question I have seen when I used to teach in MTech class, because some people are so excited, right? So you can create your own library, right? And like for example, you can create own library name is this. This is your main folder of package name. This package will have this init.py and other modules like this, math utils or string utils and other module it may have. Then you should have this file setup.py file. This file is purpose of installation. You need to write syntax into this. Those syntax you can easily get from any of the website. Right now I have not included because it does not make sense to create your library right now. Right now you need to focus is on understanding the basic concept. Nobody is going to ask you in interview, go and create your own library, right? Don't worry about this. Readme file will have description about this whole module, right? License, as I also shown you in pandas, license is the purpose of distribution, but it's optional. If you want to give, you can. And requirement.txt, what modules it is using, which Python version it is using, all the related modules it is using, it should be into this, and with the version also. So this requirement.txt will keep all the dependencies, right? So you need to create this file, install. You can install this locally by pip install and dot means in your folder that you already have. You need to install that. Use the library in Python. How you can use import my library, right? Okay, if you want to wish to publish this, you can publish on PyPy. PyPy is a basically package manager or package manager software, right? Pip is also package manager which is used to install this. So PyPy, it is a Python package manager library, you can say, which is maintained by Python Foundation. So whatever package you can create, you will register there. So it has a big library of multiple Python package. So Python has so many packages. Suppose you want to create GUI, you can use tkinter. If you want to create mobile application, you can use Kiwi, right? I think this, you can check the spelling, I'm not sure, but yeah, Kiwi. If you want to create web application, you can use you can use Flask, or maybe you can use Django. If you want to create API, you can use Fast API, right? So lots of modules are available in Python for different operation. Similarly for IoT and other thing, right? Okay, you can use those module and try to create your application. Similarly, Pygame is there for creating Python games. OpenCV is there for computer vision operations. Scikit-learn is there, right? Scikit, scientific toolkit for machine learning algorithm like logistic regression, linear regression, right? Logistic regression, linear regression, and your decision tree, random forest, XGBoost, if you hear into Kaggle competition, if you know these names, right? So these all are libraries, right? So Python has various library which kept here, which is maintained by Python Foundation, and pip command is used to install it. Okay, so this is about this module and packages, right? One more thing I want to explain you, right? This is how you can create, how Python interpreter searches for module. First it will search into current directory, then it will search at the Python path, whichever Python path you have defined. In that it will go and try to search. If it won't find in the current directory. Similarly happens also in Java, right? It try to search into first current directory, then it will search at the path. Okay, and again I am repeating this, package is a hierarchical directory or a file directory, or you can say a folder directory, which has this function. The main purpose is structurizing your project, and code reusability and modularity. That is what the whole purpose of modules and packages. Modularity, reusability, encapsulation you can also add, right? Encapsulation. So these are the core concept which help you to manage your large project. Otherwise you can't, to be frank. Otherwise you can't. Okay.